Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about IV characteristics of this NMOS transistor. This is an NMOS transistor, and here this is the IV characteristic that we're going to look for: the drain current versus drain source voltage of this device. But before we get started, if you're new here, please give me a thumbs up and hit that subscribe button and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is an NMOS transistor, and as you can see, this is gate, this is drain, and this is source of this transistor. When we want to draw drain current, you can say this is the drain current and this is drain source voltage. We have to know what is the value for gate source voltage of this device. This is gate source voltage, because the condition on gate source voltage clarify which region we work. If the gate source voltage of this transistor is less than threshold voltage of this device, then NMOS is off. But if the gate source voltage is greater than threshold voltage, then NMOS is on, and now we have to check another voltage, which is drain source voltage of this device. If the drain source voltage is less than gate source voltage minus threshold voltage, then transistor is act in a triode region. What is the relationship between the drain current and the gate source or other parameters of MOSFET in this triode region? In triode region, drain current equals to mu n, which is the mobility of electron, times the oxide gate capacitor of this transistor, times W over L, which is the dimensions of this transistor, times the difference between gate source voltage and the threshold, times drain source voltage minus drain source voltage to the power of 2 divided by 2. This is the relationship between drain current and other parameters of this MOSFET. And if we are about to draw drain current versus drain source voltage, we can draw the triode region as something like this. Sometimes we call it a linear region, because the relationship between drain current and the drain source voltage is almost linear. Okay, so this is the triode region. And what if drain source voltage is greater than gate source voltage minus threshold voltage? Then the transistor work at saturation region. And now the drain current equals to 1 divided by 2 mu n C oxide W over L times VGS minus V threshold, all to the power of 2. And we can draw drain current versus VDS as something like this. This is a straight line, and here this is the boundary between triode region and the saturation region, which is equals to gate source voltage minus V threshold. And as you can see, if drain source is less than VGS minus V threshold, the transistor worked at triode region. But if the drain source voltage greater than gate source voltage minus V threshold, the transistor worked at saturation region. As you see, it seems that drain current doesn't depend on drain source voltage in a saturation, but it is not true in the real world. This is just some assumption that we have for just now, for the sake of simplicity, just to make life easier. But in a real problem, we have a channel length modulation which make this straight line have some slope on it. We're about to model it in another video, but just for now, have this just for the sake of simplicity. And I try to solve some different problems, different numerical examples to completely understand these relationships. But try to just write it for your own good, because this is really helpful. If you draw a circuit, write some relationships, it's really helpful for your learning process. And just another interesting point is that the application of NMOS transistor depends on the different situations. For example, in saturation region, we used NMOS as an amplifier, okay? But in a triode region, we use MOSFET as a switch. We want to turn it on and off again as a switch. Here in a switch mode, actually, when it is on, it works. It had to be work in a triode region, but when it is off, off related to when gate source voltage is less than threshold voltage. Remember that. So you have to know this different situation. What is the gate source voltage, threshold voltage, drain source voltage? These are the different situations that you have to know when you want to consider the relationship between drain current and the drain source voltage of NMOS transistor. Okay guys, I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friends. See you in the next video. Thanks for watching.